And welcome to Gadget Reboot's AVR Programmer PCB Build. This is Gadget Reboot's AVR Programmer, and there'll be a link up there. And I started on the board. You might have just missed it. Speeded up with Q2 because Q2 had the collector and emitter of the transistor on the footprint swapped over, and so there'll also be a link up top to my video entitled "Working with a Bum Footprint." No disrespect to Gadget Reboot. So while the build is going on below, we started off assembling the smaller items, the resistors. So slowly work your way around the board, and then once all the resistors are in place, and move on and do the capacitors. Now while it's being built, you can see it being soldered at the bottom of the screen, I thought I'd have a little talk about the circuit here. We have a AP3012 DC boost converter, and basically that takes the 5 volts. 5 volts comes in through the USB connector on the Arduino Micro Pro and comes out on the raw pin, and through a fuse. Well, I haven't got the fuse, so I've just soldered the pads together, and that provides the 5 volts to run the circuit. The AP3012 takes that 5 volts, boosts it up to either 12 volts or keeps it at 5 volts. Q1, the FET here, determines the output voltage. The feedback pin 3 wants to see about 1.25 volts. So when the V reset line is low, R2 is out of the equation, and the feedback from this divider is 1.25 volts at about 5 volts. When V reset goes high, the FET turns on, R2 is effectively placed in parallel with R3, and so now we need to get about 12 volts to generate on the output to generate the 1.25 volts going into the feedback, and so that pin controls the voltage at this point, be it 5 volts or 12 volts. Here we have the reset enable. Now high on the reset enable turns Q3 on, which pulls the base of Q2 down, turning it on and passing whatever voltage is selected here out onto the target's reset pin. Target VCC or VTG enable. A low on that turns on the FET and allows VCC to pass out to the target. The voltage on the target is also monitored by the Arduino, and over here there are a variety of LEDs, which I think at the moment the only one that lights up is the power light, because that's permanently on if there's power. I'm not sure if the software uses these at the moment. And of course there's the rotary encoder, which allows you to step through and the display. So one of the last things to be soldered on was the AP3012, because you may have seen, if you watched the Postbag number 12, which I'll put a link to up there. I had to order them from RS, as the ones I ordered from AliExpress have been in the air since the beginning of January, and I think at some point they're going to have to complain. And the last thing to go on with the headers, and plugging the board in and plugging the OLED display in. And once all that's done, I'll move on to the next video, which I shall film shortly, which will show a little bit of testing this. I shall remove the Arduino and the display, and I'll just do a little test to make sure that these voltages are correct and that they can be turned on and off before I put the Arduino in and program it. So I'll leave you to listen to a bit of music while the build finishes. If you like the video, click on the subscribe button, click on the notification icon, and I'll see you next time.